Okay, so I said let me just make a short video on understanding why percentage errors are added in both multiplication and division. Okay, so I'll come to the full rules there later on, but I think it's important to understand why this happens. So, as a quick example, let's just say we're trying to find the area of a rectangle. Okay, and you've got basically, so for a rectangle, you're going to measure the length, and you're going to measure the width. And let's say, for example, just keep the numbers nice and round, that the length is measured to be 8 meters with an uncertainty of plus or minus 1 meter. So that's pretty big uncertainty. Okay, and the width is measured to be 4 meters plus or minus 1 meter. So then, if we want to calculate the area, well, the area as normal is just length times width. Okay, the length times width is 8 times 4, which is 32 meters. But then, what about the uncertainty? Okay. So to try to understand what's happening with the uncertainty, if you take the maximum length that you could possibly have, well, then you'd have 8 meters plus the 1 meter from the uncertainty. That would give you a total of 9 meters. And again, if you do the same thing for the width, remember you had 4 meters plus that 1 meter, that would give you 5 meters. So the total possible area that you could have would be 9 times 5, which would be 45 meters squared. Okay, just a good bit off. Then, of course, if you do the exact same thing for the minimum, the minimum length that you could have would be 8 minus 1, which would be 7 meters. And the minimum width would be 4 minus 1, which would be 3. So then the minimum possible area that you could have would be 21 meters squared. So if you think about uncertainty as being the total maximum, the maximum area that you could have minus the minimum area that you could have, and just split the difference basically between the two of them, divided by 2. Okay, then you have 45 meters squared minus the 21, which would give you 12 meters squared, an uncertainty of 12 meters squared plus or minus. Okay, plus or minus 12 meters squared. So just to compare that to the addition of percentages, okay, if you follow it through using the percentage errors, and you calculate the percentage error, the percentage uncertainty, I should say. Tendency to say error when I should say uncertainty. But anyway, we've got 8 meters, and that's plus or minus 1 meter. Okay, plus or minus 1 meter. So if you take 1 over 8 is 0.125 times 100 gives us 12.5% error. Okay. Similarly, you take your 4 meters plus or minus 1 meter, so that's basically 1 over 4, which is 0.25 times 100, which gives us 25%. So our rule says that we should basically add the percentage errors, and that should give us the percentage error in the area, or percentage uncertainties. Sorry, I'm doing it again. So 25% plus 12.5% gives us 37.5%. And if we just follow that through and just see, well, what exactly is 37.5% of 32 meters squared? Well, to do that, you just multiply 37.5 times 32 divided by 100, and that will give us 12 meters squared. Okay, which is exactly the same as what we got doing it the other way. So it should make a bit of sense to you. Okay, hopefully it should make a bit of sense to you. So therefore, your percentage error, regardless of whether you take it the maximum minus the minimum divided by 2, or you simply add the percentages, you should get the same thing. Okay. Now, just on a little side note, all right, I just wanted to show you what this looks like. So you'll see here the heavy black line is a rectangle of 8 meters times 4 meters. And that gives us an area of 32 meters squared. So the yellow shaded piece here, the smaller line that's inside that yellow shaded piece is 7 times 3, which will give us 21 meters squared. So that would be our lower bound. Okay, so our lower bound would basically our what we're saying is that our error or our actual measurement falls somewhere between that black line and that yellow, and in that yellow region, all the way up to kind of a coloured line there. If we then look towards the other side of it, we've got the positive side of it, which was the 9 times 5, I think, which is 45 meters squared. So that would be represented by this extra piece that's on the outside of it. Okay, so that means that our measurement should fall out here somewhere. So the region in which it falls is somewhere between the yellow region and the orange region, all the way around. We're estimating that it's going to be, approximately halfway. We're hoping that it will be, so we'd have 8 times 4, but in reality, we're not really sure. Okay, so we've got that uncertainty that falls somewhere, either in the yellow region or in the orange region, all the way around. Okay, so I hope that makes a little bit of sense for multiplication. Now, just one side note on division. Division follows the exact same rule. You add the uncertainties, again, the percentage uncertainties. And the reason is that multiplication and division are essentially the same mathematical operation. Okay? Multiplication of two numbers, you've got two numbers, so let's say I've got 4 times 8. Well, if I want to divide 4 by 8, then really this is the same as me going 4 times 1 over 8. Okay, so it's the exact same operation and therefore has the exact same rules. So hopefully that makes a bit of sense to you, and we can discuss it later on in class.